ebb and flow of mutation.
Okay,
in the
good
history of
afternoon,
life
Earth. This
on
is
the
Adam
planet.
Sturch, broadcasting
In other words,
from Garage
the
Art,
idea
Taos,
that
New
mutation
Mexico,
is
shifting
random
gears up to
is
rupture of
based on
plane
the
again.
untested and cheerful
Alright, I've been
assumption
procrastinating
that,
on this and thinking
radiation
about
is
how I want to tackle
arriving
it.
at the rate,
It's a little bit daunting
is arriving on
because
the
I've carved
Earth
out quite a few
at an
figures
even
here.
rate.
And what I want to do
But there's no reason
now
why it should be.
is
If
give
the
them
rate
a
of
bit of a
radiation arriving on the Earth were
by
fluctuating
modeling
for
the
any
highlight
reason,
on
you
the
would expect to
edge
see a
of
concomitant
the rupturing plane
fluctuation
and the figurative
in the fossil record. And there are many
masses.
other reasons. In catastrophism,
So,
the idea that
here we go.
have been extremely violent episodes in the Earth's history, huge volcanic outgassings, cometary and asteroidal impacts, and this sort of thing, is now pretty widely accepted. And in fact, the extinction of the dinosaurs is put down to an asteroidal impact. But go on, it would be interesting to hear you deal with the salts that tire.
Yes, I'm fascinated by these salts that get tired. I don't know, I mean, I'd be interested to get from you later a reference to the literature so I can look it up, because that sounds really interesting. Eutectic salts going backwards and forwards and getting tired. I mean, the only thing that I think offhand in response to that is that I've been thinking quite a lot recently about exactly that kind of phenomenon, melting points, and asking the question of myself and of chemists whether compounds that are fairly newly synthesized, when they're crystallized, have a particular melting point, and that as time goes on, the melting point might change, because the habit which holds the crystal in its form might become stronger, and it might be more resistant to thermal disruption, so the melting point might go up. It turns out that in the chemical literature, far from being fixed, melting points fluctuate. In the published literature, I've found differences of up to 12 degrees over 20 years. And there do seem to be extraordinary fluctuations, and most organic chemists agree that there are strange changes occur, that they don't seem half as constant as they're cracked out to be.
Keep the ice caps in place then.
Well, that might
changing the melting.
The eutectic mixture, you see, one of the things I've been thinking about is that when a substance melts, you've both got a formative field of the crystal, but the liquid phase of the substance also has a morphic field. Liquids have characteristic properties. They're not totally chaotic and formless. They have, and if it's a new substance that's never been melted before, it won't have had a sort of morphic field for its liquid phase. By repeated cooling, and I was trying to think of experiments involving cycles, of cycling a substance through cycles of melting and cooling, because there would be a way in which the number of transitions and also the endurance of the liquid versus the solid phase would tend to stabilize the morphic fields of these two phases. And in a sense, around the melting point, it would be as if there were two competing fields. And if one were the stronger, it might tend to raise or lower the melting point. So I've been thinking about this sort of thing, so I'm fascinated to hear about these eutectic crystals, and I'd love to read out the literature. I'm adopting a very traditional scientific position in one way by assuming that by putting forward the hypothesis in its most general possible form, if I said it sometimes works and it sometimes doesn't, then it would be very difficult to test, because and it would actually be irrefutable. That's advice and not a virtue in a scientific theory. And so I'm more inclined to think of it working, trying to think of it working everywhere. Now, there are many systems like the behavior of hydrogen atoms, the crystallization of sodium chloride, and all sorts of phenomena that physics has studied in great detail, which have happened billions of times, and as far as we know, for billions of years, even before this planet formed. So there are certain kinds of phenomena in nature which have happened so many times before, they're so deeply habitual, that they behave as if they're governed by eternal laws. The habits are so deeply entrenched. And I think many of the phenomena that scientists have studied particularly in the physical sciences, are of that kind. And therefore they do look as if they're governed by eternal laws. Where the difference shows up is when you look at any new phenomenon, because then you can see the habits building up. With old established habits, they might look as if they're not really habits at all, but following eternal laws. So I would say that I would prefer to think of the theory applying everywhere and to account for the apparent non-changing of many physical habits in terms of their extreme antiquity and the fact they're so deeply embedded in groups of habit, they don't change.
Sometimes you simply want to test them.
Well, you can test the theory in any area where you can do something new. New forms, new crystals, new molecules, new patterns of protein folding, new ideas, new ways of learning. There seem to be plenty of areas it can be tested in.
Is there anything that was hard to refute your theories, or what do you consider its status of? Or is it just a good idea?
It's a hypothesis, which what a hypothesis is a guess about the way things may be. And what I've done is contrasted this guess in a variety of areas, the realms of memory, crystallography, morphogenesis, instinct, behavior, transmission of learning, behavior and evolution of social groups. So I looked at the predictions of this way of looking at things compared with the standard way of looking at things. And in every area one finds that there's a whole range of shadowy phenomena where the evidence for the conventional position is very weak indeed. And one sees that that's actually a guess too, which is in most essential areas unproved even now. So one's got one guess versus a much more common and habitual guess. And there are other guesses on the market too. Well, a failure of experiments to show morphic resonance would falsify it, except that falsifying scientific theories is never, people often go on as if they say, Popper says the ideal is to falsify theories. I don't know a single example of science proceeding in that manner. Most scientists are trying to prove theories. And they may try and falsify theories of their rivals, which is the way it usually happens. But and it's a kind of dialectic then. Science becomes a dialectic between rivals. And science is full of ego rivalries. Well, most people think that this is terrible vice, but actually it's one of the motors of competitive science as we know it. If somebody puts forward a theory and someone has a rival theory, and then there's the way the contest is decided is by experiment. The rules of the scientific game. Experiments are usually designed to test between rival hypotheses, rather than testing a single one in isolation. And I'm putting forward a variety of tests which test between the idea that nature has this habitual tendency as against the conventional idea, which is always that nature is governed by immutable, changeless, eternal laws. And some tests may be inconclusive. Some tests may, I think, favor the idea of morphic resonance. If all the tests that are done fail it, if it fails, if it looks as if things are governed by eternal, changeless laws, that there's no evidence for any incremental change in time in any area, but everything goes on as if it were governed entirely by laws that were already there to start with, I'd find that rather surprising. But failure of these experiments would actually support that view, and the conventional view would then, for the first time, actually have empirical evidence in its favour. Because this would be the first time it's ever been challenged. And if those challenges fail, it would strengthen it. So these tests, I think, are in everybody's interest. And if they support the idea of morphic resonance, then indeed it would show that is not a perfect one. It's maybe the idea of a memory in nature, morphic resonance, however crude the theory is in its present preliminary form, it would be a better theory and a theory more worth developing. And the question is the field connection in quantum non-locality in Bell's theorem and the Einstein-Rosen-Podolsky paradox, that kind of quantum non-locality related to morphic resonance? Are they two aspects of the same phenomenon? That's the really interesting question in relation to existing physics. And nobody knows the answer. I don't know how morphic resonance as conceived would fit with quantum non-locality, which it does in fact involve a past, because both systems originate from the past. It's to do with a system with a past, which is, I would say, the very existence of these particles is a kind of resonance from their own past. And I would say that there is a kind of morphic resonance link, and probably that's what it might be. But I can't fit that into the formalism of quantum theory, because I don't know it. I'm not a quantum theorist, and to work with those equations with any degree of subtlety would require a deep understanding of the subject. On the other hand, J.S. Bell, the inventor of Bell's theorem, has been in correspondence with me. He's read both my books and has sent me his latest book. So we've been in a correspondence about the possible connection between morphic resonance and his own theory. He's perfectly intrigued by morphic resonance and morphogenetic fields, and he thinks they may be connected with his own theory, but he can't see how, because there's nothing in the conventional physics which has yet proved. Because it's so based on eternal equations, the idea of Schrödinger's equation is a kind of eternal Platonic form that governs all quantum processes from the beginning of the universe to the end in exactly the same way. That's the kind of inherited formalism of quantum mechanics, and that kind of mathematics, which postulates eternal Platonic type forms, is not going to be adequate for modeling an evolutionary universe. And so it's not clear how the bridge can be made, or even whether that connection, but I think there must be some kind of connection. There can't be lots of totally unconnected types of non-locality in the universe.
Rupert, why not replace the Platonic models with fractal models, and then say that time itself is the morphogenetic field? That it is some kind of fractal topological manifold and so the repetition or the connection to past states is really accomplished through resonance within the fractal, and then we have a model for resonance because it's familiar to us from other domains of nature.
Well, I don't see quite how there's a sense in which the fractal is a new mathematical model that gives us the same idea that the ancient idea of the microcosm mirroring the macrocosm. The idea of different levels.
Well, but not only different levels, but different points on the same level, in the same way that the past occupies a relationship to the future of formative anticipation, so in a fractal do early portions of it anticipate later forms. So it is like a prediction, a self-fulfilling prediction is what a fractal is. It predicts by virtue of its past states. They define what its future states will be, exactly in the same way that I imagine the morphogenetic field defines what future states will be. The fractals that have been talked about to date have been used to describe spatial phenomena, coastlines, molecular arrangements, distribution of flowers in a meadow, this sort of thing. But if instead you thought of fractals as descriptors for the temporal dimension, and replace the notion of a flat or slightly curved manifold with an actual fractal surface over which events were flowing, and flowing over patterns which repeated themselves at many, many levels in resonance with previous similar patterns, then you would begin to have a mathematical picture of how the morphogenetic field would work, and you would also have found a phenomenon in nature upon which to hang it by saying time is obviously it. It's just that we are so ingrained by Newtonianism to accept time as an abstraction, as something not having equal status with the other three dimensions, that we've overlooked this fact. And yet, obviously, that is the carrier wave. That's why you would speak of the presence of the past. What then can it be but time, past time in the present?
Well, it is past time in the present. But the fractal wave, you see, why I don't like the fractal model taken to any great extreme is because any kind of mathematical modeling given the whole nature of mathematics as it's practiced, fractal mathematics is conventional paradigm in the sense that you create an equation and you generate this form. The equation itself is not subject, the governing equation is not subject to evolution. It's generating the same form, and it would go on generating the same form right into the future. In other words, it would be a kind of determinism based on a kind of Platonic or Pythagorean ideal form, the fractal equation, which generates the fractal. And I don't understand evolution as happening like that. I don't think it's as deterministic.
Well, you're right that as they are presently understood, it would generate, however complicated, ultimately a determinism. But I wonder if we're just not mathematically sophisticated enough to inculcate into the fractal equations sufficient randomness within the fractal constraints to begin to get the kind of complexity that we meet in the real world. That would seem to be what is lacking, is a random factor that causes the fractal equation to skew toward production of ferns, and then suddenly to switch over to feathers, and then to river systems, and then to industrial economies or something like that. But if it can do all these things, it can model all these things, but as you say, in a deterministic way. But maybe we don't know enough about them yet, and that there may be higher dimensional or higher order fractals with a degree of self-determinacy or autopoiesis built into them. I think this must be so because I think the world we're living in must be such a world, and that we are these fractals. We are essentially three-dimensional expressions of DNA. And all the DNA is the same, and yet each one of us is different, and yet 10 of us are like any other 10, and yet different. And we, as human beings, have the same quality, and so do our cities and our nation states and the continents we inhabit and the religious systems that we're inside of. So it seems to me the fractal model may be the one which holds out the greatest hope for a formalizing of the morphogenetic field. All other fields are fractals. The electromagnetic field, the radio wave, all of these things are found to have this quality. And in fact, the development of this kind of mathematics initially was in an effort to describe the field phenomenon, Fourier transforms and that sort of thing. So then why not this one? And then that vastly narrows down the mathematical domain in which you have to search for a formal description of the morphogenetic field. It would also yield a perfect theory of history, because that would be part of the morphogenetic field.
Well, I suppose that one of the problems I have is that I'm not so fascinated with mathematics. I don't think that most mathematicians think that the maths is more real than the thing it models, that the equations of the universe are more real somehow than the universe. They were there before it, after all. They were its source. They were prior to it, both logically and temporally. They're the more real thing. This is the Platonic tradition.
Platonism.
And this is alive and well. I mean, its latest, greatest exponent in the bestseller lists of the last few months is Stephen Hawking, who, as a perfect exponent, really, of that Platonic view of the eternal intellect, the eternal mathematical mind, which somehow is over and above the universe. The mathematical mind of God, in some sense, is there before and prior to material bodies. And as one of our British journals put it, that Stephen Hawking is the closest thing we have to a disembodied mind. And it's a perfect, you see, in a sense there's a perfect, I think the reason for his mythic quality, because he is a mythic figure, mythic power, is because of that. And the vision was totally consistent with it. And so I don't really, all mathematics tends to have that quality. And I would think of the fields not as something which to grasp we have to model mathematically, but as something which I think of them as much more like living things, and our models would be much more and more appropriately based on an intuitive sense, a living sense of things that we actually learn from experience as living things ourselves. So the models would be much more communicated by seeing how they correspond to our actual subjective experiences, the kind of things that we experience.
So through ordinary language.
Through ordinary language, through the realms of the imagination, through our understanding of memory, through the mind, through the power of hopes, fears, desires, fantasies, through the experience of our consciousness as the realm of the possible. And so these are much the best. Mathematics is a tiny fraction of a formalized modeling of the possible, which is constrained by very particular rules and is entirely, so far in the whole history of the subject, under the aegis of the Platonic spirit. And I just think that to try and pin it all to that just seems a limitation that one doesn't need at this stage. I mean, it may be helpful, it may be interesting.
My God, I see why they're alarmed now. Yes, well, I'm sure you're quite right. So what you're really calling for is the rebirth of poetry.
Well, and all kinds of lived experience through which we directly relate to the world. Because a science which helps us directly to experience nature, and actually when we walk in the wood, understand it more deeply and more profoundly than we do now. Something that tells us something we don't know about the quality of woods, trees, the nature of the bird song we hear, how they communicate. I mean, I think they're just call signs, their songs, and the actual message is, as it were, telepathic once they've tuned in through the right calls. This kind of world we might come to live in and actually experience. And the mathematical models just wouldn't seem, I don't think, terribly interesting or important.
Well, so this is the connection to the psychedelic experience, the felt realm of immediate perception, that somehow with the psychedelics we're coming into the full spectrum of our experiential birthright. And you're saying that this theory, correctly assimilated, brings us also into a full appreciation of the felt spectrum of experience that is our birthright.
It makes us realize that we're living in a magical world in which there are unseen connections, that the power of thought, imagination, and dream actually has a reality. And our ancestors lived in such a world. And the whole medieval and animistic world and the worlds before that. And most
Alright, I think that's working. It's progressing pretty slowly, and I just realized the entire upper portion that I was just working on is in a pretty bright highlight. At least it is when I look through this viewfinder here. So, a little screen. So, sorry. I'll have a photo of it, of the process.
It's a living thing.
That might be it for the moment.
As living things. And
Watch the
the
brush out, take
disembodied
a
mind
look for a
approach
second.
of totally abstract mathematics, seeing the universe as if from without. The whole point of the mechanistic picture is that you withdraw yourself from the world. You see the world as a spinning ball, as we now finally, through the space mission, come to see the world. It's a total confirmation of the initial leap of the mechanism of Copernicus. It's a proof of the Copernican theory in the most dramatic form, because theirs it was to step off the Earth, which everyone else had taken the Earth as the centre from which to model things.
Okay,
It's the
here, let me
centre from which we
zoom in and
experience them,
pan over
and it's true to our
what
experience.
I've done here, in case that was completely
Saying
washed
that's not
out
the centre at all. And
by the
Kepler
light.
in 1609 wrote the early work of science fiction, The Dream, when he imagined himself being in a transport, a visionary state, transported to the moon. From the moon, on the moon, encountering
Alright, I think
strange
that's showing
creatures
up.
that lived underground and
So,
crawled out from
as you
under
can
rocks.
see,
And
just
looking back at the Earth
very
and seeing the
lightly
Earth spinning on its
touching
axis,
the
just as
edges
astronauts and our
of the
cameras see it
outermost
from the moon.
figures.
And using this in his book, The Somnium,
to light them up where the light is spilling out of the rupturing flame.
Moving, even though they themselves experience the rest of the heavens to be moving. And this is the thought experiment.
So that's going to take quite some time.
And
I think that might be it for the moment. I may do another session on this later, but I'm not sure. So I'm going to go ahead and cut this here. Say thank you for watching. That's Adam Sturch broadcasting from the Garage Art, working on oil painting, Rupture of Plane. Have a good night, everyone.